Beauty. This is like one of the most beautiful campuses I've seen. It's really lovely. So, let's see, math. So I want to start by saying a few things that I think make mathematics unique and mysterious in a special way. There's something strange and mysterious about mathematics. So I'll talk about that. And after outlining the mystery, I will suggest how three figures from the Catholic tradition can help us make sense of these strange features of mathematics. One figure is St. Augustine, another is St. Thomas Aquinas, and the third doesn't have a saint in front of him because he had some trouble with the church, Galileo. Okay, so mathematics, it's an area of human discovery. We're really sure of the truth, right? So in physics, chemistry, biology, all that, we have some ideas, but we're not sure. Mathematics, we have mathematical proof, we're pretty sure. I mean, you look at the biology of 2,000 years ago, we got some things right, but mostly it's pretty bad. But mathematics from 2,000 years ago is pretty much as good as it was. So mathematics gives us this great amount of certainty of the truth. But I think it's also the area of human knowledge where we have the least idea of what it means. So we're sure it's true, but what it means, we're not at all sure. Right? So, you do geology, chemistry, biology, physics outside of the fundamental stuff, like quantum mechanics, I don't know, but like non-fundamental physics, we know what we're talking about. We know what a fault is if we're talking about geology. We know what a molecule is when we're talking about chemistry. But in math, we don't know. But on the other hand, we're much more sure that it's true than what we say in geology or chemistry or biology. Since the ancient Greeks, we've been sure, for instance, there are infinitely many prime numbers. They've gave us beautiful proof of it. But we still have very little idea, barely any more, maybe even less than they did, of what numbers are. But we know there are infinitely many prime ones. So mathematics gives us uncontroversial near certainty and deep mystery. And at the same time, it's often quite difficult. And yet, and this is also somewhat surprising, perhaps, extremely useful. Let me start with some ways that philosophers have thought about mathematics. So Plato thought that we have this physical world around us, but besides this, there's this world of forms, which has things like the true circle, or the true beauty, or the true good. The physical world has only imperfection. There are no circles in the physical world. There are no lines, there are no triangles. They're just these things that look kind of like this. This is not a circle, this is not a triangle, this is not a line. But they remind us of things that exist in this non-physical way that Plato thought we knew about. So there's this Platonic world where you can have genuine triangles, genuine numbers, and so you go to modern mathematics, general categories, vector spaces, manifolds, division rings, all sorts of things. But this leads to three problems. First, it's still mysterious. What are these things? What are these numbers that are not physical? What are these lines that are not physical? What are these division rings? That's the first one. Second one, we are evolved apes. How do we get access to this non-physical world? I mean, how do critters that have evolved and access the world through our senses, how do they get access to these non-physical things? And third mystery, why is the study of these things from outside this physical world so useful in the physical world? So this is very puzzling. There's a different kind of approach, sort of diametrically opposed to it. So Platonism is on the one side, takes mathematics really seriously, says there are these real mathematical objects that really exist in a non-physical way, but perhaps even more really than the physical things. On the other side, we have what people call deflationary theories. They're sort of making mathematics smaller, make it less mysterious, more accessible to apes like us. So there's a couple of different versions of it. I'll just talk briefly about two. One is called logicism. The idea there is that mathematics is the study of what we can prove from axioms. So it's not like we're looking at what the numbers really are. We make some assumptions. Okay, there's a zero. After every number, there's a successor. We make a few more assumptions, then we just say, what could be proved from these assumptions? Are the assumptions true? Who cares? But we'll check what we can prove from these axioms, these assumptions. So the idea is we can escape from talking about the truth of mathematical statements to what can be proved. This approach has ran into a serious problem in the 1930s. The logician and mathematician Kurt Gödel showed us that facts about what can be proved are very much like facts about numbers. Like the idea of what can be proved is what abstractly there's a proof for. Well, proofs then end up being these abstract entities that are just as abstract and mysterious as the numbers. In fact, you can encode them as numbers. And the potential is, and so it turns out we don't really escape the mystery of what makes mathematics true by moving from truth to provability. A different kind of approach that's always popular and always feels, I think, to people like there's something kind of right about this, is that mathematical things like numbers, they exist in the mind. They're not like really in the physical world, they exist in the mind. They're mental entities, maybe even fictions like Sherlock Holmes. But now, if they're like that, it's puzzling why mathematics is objective. I mean, if we're making them up, then it's just puzzling why we don't just get to make up anything we want. Why is it that our calculus teacher gets to sometimes say, this is wrong? Because, I mean, if we could just are making up these fictions, then we should be just as right as they are. And even more so puzzling why it's useful. I mean, studying Sherlock Holmes is not useful to the police officer trying to solve real-world crimes. Why should studying these fictional entities be useful to engineers? So Platonism has these problems of how it works for apes like us. Deflationary theories work nicely for apes like us, but have other problems. Okay, I want to talk about the second. I'm going through the three words in my title in reverse order. So next I want to talk a little bit about beauty, and specifically the beauty in mathematics. So I just want to note, I thought about this a little bit. Maybe some people have more ideas on this, but I thought about what kind of beauty there is in mathematics, and I thought I could find three different kinds. First, we've got beautiful mathematical objects that are generated by simple rules. Fractals are a famous example. But also other things. Knots, for example. Sometimes things that are not visual. The beauty of mathematical objects is not always a visual beauty. It might be some kind of very abstract object that's not perhaps particularly visualizable. So that's one kind of thing. Mathematical objects that are beautiful. Maybe some people find some numbers beautiful. Some people maybe find pi beautiful. Second kind of beauty in mathematics is there are beautiful mathematical facts. And some of these are very ancient ones that we've known. There are infinitely many triangles you can draw. But all of the triangles, at least the perfect ones, their angles add up to 180 degrees. There are infinitely many natural numbers, 0, 1, 2, 3, and so on. Each one can be written as a product of primes, and only in one way. Any polynomial of degree n has exactly n roots, counting multiplicities. All the non-commutative division rings are infinite. There are only 5 Platonic solids. There are only 5 convex figures that are basically the same at all the corners and faces? 5. You'd kind of think, if I was guessing, I would have guessed like infinity or none, maybe. But it's 5. It's very strange. Or 1, but no, it's 5. Very strange. And one finds this all the time in mathematics. So you do something, and I shouldn't say literally all the time. I mean I mean hyperbolically all the time. I mean, sometimes we find mathematics and the facts turn out not to be so beautiful. But we very often and surprisingly just find ourselves with solving some mathematical problem, and the answer turns out to be kind of pretty. So like, this is just, sort of fun I was having last couple of weeks as I was working on this applied mathematics problem so this is a kind of weird problem for a philosopher to think about. There's a story I could tell why I was interested in this, but I was just it had nothing to do with philosophy. But suppose you've got something like a drone with a camera flying around, and the drone knows which way is up and can see through the camera. And there's 2 landmarks on the ground. I marked them here, M1 and M2, and their positions are completely known. And the question is, can you find where the drone is by looking at the camera images of the 2 landmarks plus the drone's knowledge of which way is up, which it can know by detecting gravity. So can it do that? Well, it turns out, depends where, at least if the landmarks are not at the same height, it depends whether you can find out exactly where the drone is, depends where they are. And so what I found was if it's in this sort of cone emanating upward from the bottom landmark, you can find exactly where the drone is. If it's in the downward cone emanating from the higher landmark, you can also find where it is. And then I knew there's also some, with the exception of a line going through the landmarks where you can't actually know, things look confusing on that line. And then I found there's actually some more places where you can find exactly where the drone is. But my initial calculations were suggesting something really messy. I had some graphs that had like these very messy things, multiple things. And it turns out those calculations were just wrong. And the answer turned out, and there's one more thing, this perfectly flat plane going through the 2 landmarks. That's another place where you can find out. And so this is like something that just happens sometimes in mathematics, is you just are working on some problem, and the answer turns out to be surprisingly nice. Sometimes what happens is like you make a guess as to what would be the nicest answer to this problem. And not always, maybe, I don't even know if in a majority of time, but surprisingly often, that turns out to be, yeah, that's right. Or that with maybe some one exception or something that you hadn't thought of. So just so mathematical facts can be beautiful and surprising. And the last kind of beauty of mathematics is one that mostly mathematicians notice. It's that the proofs in mathematics can be beautiful. They're not just annoying things to do. The good ones are really beautiful. Okay. So why is mathematics beautiful? Well, here's one option. This is what people call subjectivism. Beauty is in the eye of the beholder. Beauty is just what you think is beautiful, and so it's just purely subjective. There's nothing to explain, it's just subjective. Well, a couple problems with this. One is just, it's not true that beauty is in the eye of the beholder. I mean, here's my proof of this. It's not a mathematical proof, but, it's just obvious. I mean, I drew this, somebody else drew this, and it's just obvious that I'm so much better, right? Like, it's just objectively true. Right? So beauty is obviously objective, right?
We should be hanging down up in the Louvre.
Right, so, okay. All right, so that's sort of my quick one answer, but there's another thing that I could say. Look, suppose we say beauty is actually just subjective. It's just something we made up. We still, remember, we're evolved apes. Why did we evolve to find mathematics beautiful? Suppose beauty is just something we've made up. Why did we evolve to find mathematics beautiful? Even if it's subjective, it's still strange. I mean, mathematical beauty was not something our ancient ancestors knew about. I mean, at most, maybe they could count to 5 or something. They had some idea of, how objects thrown maybe describe a parabola. But besides that, really, they didn't see mathematical beauty when they were off evolving. Seeing mathematical beauty did not help them gain mates. It's not clear whether it does these days either. And it didn't help them survive. At best, it's some kind of thing that evolutionary theorists call a spandrel, where you've got, you're evolving to get something, and then as a side effect of that, you get something else. So maybe, there's like this, you could maybe tell this kind of theory as to why humans have a perception of beauty at all. Well, our perception of beauty is tied to finding good mates for ourselves, because good-looking mates are healthy mates, and healthy mates will make our genes get passed on. Okay, so beauty of fellow human beings. We can give an evolutionary story for why we might appreciate it, and in a way that maybe it doesn't have anything objective to it. It's just a good sort of proxy for figuring out what a good mate is like. But mathematical beauty isn't like that. I mean, you saw those objects I had on a couple of slides back. Good mates don't look like that. In fact, it's very hard to see what they have in common with any of these pictures, really. Maybe symmetries. Symmetries, maybe there's something to symmetries. But there's a lot more to beauty than just symmetries. So maybe mathematics. So if we just evolved to get this subjective sense of beauty as just a side effect of something else, maybe we just it's a glitch in our system, and we just happen. The system is designed to show us good mates and maybe edible plants, maybe or something. Then it's just a side effect that it makes mathematics beautiful, and then mathematics becomes just kind of meaningless pleasure. And that doesn't seem satisfying. At least to me as a mathematician, it doesn't seem like a satisfying view. So I don't think subjectivism is a good answer. And finally, subjectivism leaves completely untouched this difficult problem of why mathematics is so useful. And it's just like the deflationary theories. It's hard to see why mathematics would be so useful. And specifically, why is beautiful mathematics useful? So I want to talk a little bit about this usefulness and the beauty in the universe. Something changed in human science around the time of Copernicus. About 500 years ago, things changed. And what changed, I think, was specifically physics. And what changed is that people started looking for beautiful, elegant, and simple mathematical theories to explain the physical world around us. People like Aristotle did all sorts of, 2,000 years ago, 2,400 years ago, did all sorts of science, but they weren't looking for elegant mathematical theories generally that are true. Something changed. So, so before Copernicus, we had like the leading theory of how the solar system worked was that, we've got the Earth at the center, and around it kind of circle the sun and the planets, but they don't just circle the Earth in a circle. Oh, that would be too simple. That just wouldn't fit our observations. If you just look at, the positions of planets in the sky from day to day, if they were circling, they would be just sort of progressing all the time, but they don't. They sometimes start moving backwards and doing other things. It just does. It's not that. So what they ended up saying is what happens is this. You've got the Earth in the middle, and then you've got these circles, and they don't move on the circles. Instead, there are circles that rotate on the circles, and on those circles, there are further circles that rotate, and sometimes you can add a couple more. And if you did enough of that, you'll be sort of circling and spiraling around circles, kind of like a spirograph set. You got something that actually matched our observations, our astronomical observations pretty well, but was really kind of messy. But they were okay with that. Until along came Copernicus. And Copernicus said, no, look, I have a much simpler story. The sun is in the middle, then all the planets go around it in perfect circles. And then there's a little bit of variation, like the moon goes around the Earth. That's the one sort of thing that isn't quite the same. And it's a beautiful theory. It's wrong. It's wrong, and it actually didn't predict things quite as well as the older theory did. It's wrong because they don't actually go in perfect circles, they go in ellipses, it turns out. But the idea of looking for beautiful mathematics behind things, simple mathematics, caught on. Here's a sort of famous fact. Simpler theories are pretty much never the best fit to the data. Well, this is simple and beautiful theory. So here's one. Suppose in the lab, I've gathered these red points here on my graph, and I want to think, what is it? Well, any scientist will look at it and say, that looks like a line, and we'll draw this line through it, calculate this line, and say, okay, that's my theory. In fact, in this case, it's, I think, a line with slope 1, particularly nice. And all the points are pretty close to it, and it looks pretty good. Except it doesn't fit the data perfectly. If I just wanted to fit the data perfectly, I would do a fourth degree polynomial. It's right here. It goes through every single point, right smack through the center. It's designed to do just that. It's ugly. It's not simple, it's messy, but it fits the data better. But we prefer the simpler and more beautiful theory, even when it fits the data less well. Here's something I call Pruss's theory of gravitation. So there's this guy named Sir Isaac Newton, and he came up with this theory of gravitation that it's the force is like this, satisfies this formula. The force is inversely proportional to the square of the distance between the two objects. Here's my Pruss's theory of gravitation. It looks similar, except the power of in gravity is this. It's not 2. It's this. I haven't actually done the calculations, but if I have enough zeros, my theory is as good as Newton's theory for predicting the solar system. Now, if I came around and, in Newton's time and said, this is my theory, and look, I've had enough zeros to make sure it has exactly the same predictions, I guess it's a toss-up as to which of us wins, right? So I should at least, get half of the honor he does, because I'm just as likely to be right as he is. Well, you would laugh, right? I mean, just as you're laughing, right? Because this is the beautiful one. And so we think, yeah, that's surely the more likely one. Now, sometimes people think, okay, we go for the more beautiful theory because it's just more convenient to work with. Or maybe we just like it more. But if that was so, then we shouldn't trust the beautiful science that we come up with. But the beautiful mathematics is useful. It describes the world. And this is strange. Why is the beautiful mathematics describe the world? Okay. So we've got this innate mystery of mathematics that is just kind of, what is this stuff about? We've got this mystery that it's beautiful, and then we've got this puzzle that, especially in physics, the beautiful mathematics is useful. So now let's move to sort of things from the Catholic intellectual tradition that might be solutions to some of these problems. So I'm going to start with St. Augustine in the 4th century AD. He had read Plato and Platonists. He was very interested in these guys. And he liked this idea that there's this world of non-physical realities like numbers and abstract things like justice and goodness. And he wondered where these infinitely many numbers lived, where these things like perfect justice lived. They obviously don't live in our world. And he had this idea that all of these abstract things are ideas in the mind of an infinite God. And this kind of tames the infinity of the numbers. It makes you've got this infinity of numbers, but they're all somehow contained in the mind of this one being. One professor I knew, retired mathematics professor I knew, had this history of mathematics book. He wasn't a Christian. I don't think he believed in God, but he thought that the Greek religion, which had gods that are finite, they're like basically superheroes, sometimes not as nice as superheroes, but not as bad as supervillains, but that these finite gods made the Greeks kind of scared of infinity, because infinity was bigger than the gods. And he thought that this kind of kept back Greek mathematics, which wasn't willing to embrace the infinite. And that it took, he thought, Christian mathematics to feel okay with infinity, because the infinity of mathematics was smaller than the infinity of God, and so it was kind of more tame. And then you could sort of talk about infinity as such and build calculus, which is all about that. All about infinity, that is. So, in Augustine's Christianity, God is even greater than the infinity of mathematics. And it's kind of like the mind-dependent theory of mathematics. So I said, it kind of sounds right when we think mathematics is about things that exist in the mind. But if it exists in the mind, then it doesn't seem objective. It seems subjective, and then you wonder why it fits anything, why it's true. But Augustine's solution is, well, it's mind-dependent. It lives in the mind, but not our mind. It lives in the mind of God. The one being who is sort of the foundation of reality and the creator of the universe. That's why it's objective, because it's not just something we've made up, but it's about God's mind. And so this, I think, kind of story, that mathematics is about the mind of God, answers many questions about mathematics. So let me just give some. So first one was the one I started with. What are numbers and other mathematical objects? Well, they're ideas in the mind of God. We know what ideas are. Now, God is mysterious, but at least we have some idea of what ideas are, because we have our own ideas. So mathematical objects become less mysterious, because they're like our thoughts, except they're God's thoughts. How do we know them? This was this question of us as evolved apes. How do we get hold of these non-physical objects? Well, you can say God knows his own ideas because they're his ideas. It's easy for God to know his own ideas. And then he creates intelligent beings in his image, and our thinking matches his ideas. So we know them because we're created by this being whose mind is the housing for these mathematical ideas. You might ask, why is mathematics worth doing? Well, many answers to that, but you get a sort of one extra answer than you got from just it's useful or it's beautiful. It tells us a bit about God's mind. It's an interesting kind of motive you could have for doing mathematics. Why is it beautiful? Sorry, I kind of switched here. Sorry. Well, God is beautiful, and mathematics is ideas in the mind of God. This is something that I find very striking. If you look at, I don't know of any exceptions of this. There might be some, maybe some of you know some exceptions, maybe, but I don't know of any. All the religions really like beauty. You look at beautiful religious artifacts across all religions, they tend to be beautiful. People, or at least try to make them beautiful. Sometimes you fail, right? You say not all artists are equally good. Sometimes you try, but everybody's trying for beauty. There's some kind of recognition in religion of kind of a beauty in God or gods or whatever the ultimate reality is. There's something about that, and I think they're all onto this idea that God is perfectly beautiful. There's still a puzzle, I think, here. This is one I don't have a great answer to. What about the ugly mathematics? Those of you who've done some things like engineering and things like that, maybe sometimes physics, will find there's ugly mathematics too. It's messy, nasty formulas. My little problem with the drones had a lot of messy mathematics, and before I got to the lovely geometry. I don't know. I don't know quite what to say about the ugly mathematics. Maybe it's just ugly from our point of view. Maybe it's part of larger undiscovered patterns that are beautiful if we saw the larger pattern. I don't know. Why does our sense of the beautiful extend to mathematics? So I said, it might make some sense why we would have a sense of the beauty of a mate, but why of mathematics? Well, if evolution is not the only source of our, let me put it this way first. If evolution is not the only source of how we function, but God is involved in some way, then we can say, well, God gives us a sense of wonder and beauty that goes beyond the wonder and beauty of our mates that's needed for natural selection. This is perfectly compatible with natural selection. God could have designed the world so that we would be naturally selected for a sense of beauty that, even though it might be evolutionarily designed for finding good mates happens to, and God planned it so, also reflect beauty in other things, spiritual things, mathematics as well, maybe. And finally, why does beautiful mathematics describe the universe? Maybe God wanted the beauty of the world to open us to the beauty of God. So that's some things you can get by thinking about Augustine's solution of putting mathematics in the mind of God. We'll talk a little bit about the two other figures. One, this is the Thomistic Institute. So St. Thomas Aquinas. What I want to get out of Thomas Aquinas, so this is, now we're in the 12th century, so we've skipped forward a number of centuries. We've got a philosopher a little more influenced by Aristotle than Plato, perhaps. And he worked on many things. The problem I want to think about here is this. We have a method by which we do mathematics, and it's logic. We do mathematical proofs by logic. How? How does logic get us to mathematical truth? Well, I think for that, we might be able to make some progress if we get two insights from Thomas Aquinas. So Thomas Aquinas, one of the things he thought about is, what is possibility? What makes something possible? And he thought, things are possible if God can make them happen. Right? So he's got a theory of possibility. Possibility is God's power. And God's power extends to things that are logically coherent. It doesn't extend to non-coherent things. God cannot make things that are a contradiction. So God's power, on Aquinas' view, extends to things that are logically coherent and makes them possible. So in a way, on Aquinas' view, logic ends up, I don't know if he ever puts it quite this way, but it ends up basically being a study of God's power. What can God do? He can make 2 + 2 be 4. He can't make 2 + 2 be 5. That would be a contradiction. God is not a God of contradiction. So God's mathematical ideas, we could then take Augustine's idea that God's mathematical ideas are things in God's mind, but they are ideas in the mind of God about what God can do. And so logic and mathematics end up being intertwined. And then my third figure. So this is the one who doesn't have saint in front of his name. Well, this is Galileo. So we skip forward another couple centuries, and this is a very famous passage from Galileo. Philosophy is written in this grand book, which stands continually open before our eyes. I say the universe. So in case you didn't get what the metaphor was, the grand book is the universe. But cannot be understood without first learning to comprehend the language and know the characters as it is written. So you can't understand the universe. The universe is a book, but to understand a book, you have to know the language and the writing system of it. Right? It is written in mathematical language, and its characters are triangles, circles, and other geometric figures, without which it is impossible to humanly understand a word. Without these, one is wandering in a dark labyrinth. I don't know if, maybe dark labyrinth, maybe a slight overstatement of how science was going before Galileo, but it's not too bad for physics before Galileo. And so, suddenly with Galileo we realize to do physics we need to do mathematics. Right? So you read a book, you eventually learn the genre of the book and the language of the author. Without those, you don't understand the book. If you don't know whether it's fiction or nonfiction, whether it's science fiction or crime fiction or mainstream fiction or fantasy, you don't really understand it. You have to sort of get something about a book and the language it's in and the style and everything to understand the book. I think the Dark Labyrinth was a time when we didn't quite get the book of nature. We didn't realize what language it was written in. And then suddenly, around Copernicus and Galileo and Bacon and some other people, we start getting it. We have what people call the scientific revolution. We have this insight. You look at this mathematically. You find beautiful mathematics that fits stuff. You're going to do better than wandering in a dark labyrinth. And I think the success of the scientific revolution here depends on this idea of a creator who loves beautiful mathematics, which is, I think, what Galileo is getting at. I mean, he doesn't mention God here, but look, it is written. I think he means this quite seriously. It is written. There is a writer behind the universe. It's not just random stuff that just happened to pop into existence at random, and then we kind of hope maybe that random stuff is kind of described by some beautiful mathematics. You just wouldn't expect that, right? I mean, you just wouldn't expect beautiful mathematical patterns. It was just random, or at least not ones that would be throughout and useful for prediction and so on. So I think the success of the scientific revolution depends on this idea of a creator who loves beautiful mathematics. And so elegant and beautiful mathematics is useful because God chose to create a world that embodies this mathematics. And if that's right, then here's just sort of, let me make first a historical point rather than a philosophical point. I think this is correct as history. I think the scientific revolution was built on this conviction that people like Galileo and Newton and others had, that the world is built by the creator who has an appreciation for mathematics and wants to make a world that fits with this beauty, that exhibits some of this beauty in its physics. An atheist scientist is cutting off that branch that modern science grew up on. Now, what happens when you cut the branch you're sitting on? Well, there's two possibilities, actually. I want to be honest here. This is not like a solid argument against atheism. I'm just saying there's a danger here. When you cut a branch you're sitting on, there's two possibilities. One, you might just fall down and die. Or you might grab another branch that's nearby. Right? So there's a serious question. Is there another branch available that you could use to do the same thing that this idea of a creator who loved beautiful mathematics creating the world did for science? I don't know. A lot of philosophers of science kind of feel, well, maybe not. I mean, maybe all we have to do is just assume that beautiful mathematics fits the world, but we can't say anything about why. Just leave it as a mystery. I find it unsatisfying. I want to say something more. But maybe there is some clever branch you could grab and try to hold on to. Okay. So let me end, though, with something like a little bit of an argument for the existence of God. So if you believe in God, if you're a theist, you believe in God, that lets you say a number of things about mathematics. It gives you a kind of theory of what mathematics is and how it works. It's true because mathematics describes ideas in the mind of God. It's knowable because God created us in part to know it. It's beautiful because God is beautiful and his mind is beautiful. It's useful because it applies to the world, because God wrote the book of the world in its language. So if you're a theist, you have an answer to sort of a number of sort of puzzles about mathematics: why it's true, why it's knowable, why it's beautiful, and why it's useful. You also have something to say about logic. What logic's about, it describes the otherwise unlimited power of God. And then I'll just say, look, if you've got a theory where one idea explains many different things, then that's an argument for that theory. Here we have one idea, God. It explains a number of things about mathematics. So we have it's some evidence that there is a God. Now maybe you can have a different theory. Maybe some of you in the question period will offer other theories that will do the same thing, and then we can have a discussion which theory is better. But it's a theory. It does that, and it explains a lot of things. So probably there's a God. I say here, I have this picture of Leibniz, a Protestant thinker. Leibniz thought you could argue from mathematics to God. Maybe not in some of these ways. This idea of mathematics as describing ideas in the mind of God is something that was very important for him. And of course, he is one of the co-inventors of the calculus, one of the people who tamed infinity for us. Thank you.
Thank you, Professor Pruss, for such a wonderful talk. Now we're going to open the floor for a couple of questions.
Thank you very much for a beautiful talk, and I would like to emphasize the term beautiful. The talk was very beautiful.
Thank you.
Very consistent. I had probably three, but I will try to ask two questions first. First thing, it seems to me that you're being slightly uncharitable to the Greeks regarding the beautiful form part. And it looks like it is because a monotheistic culture looking at a polytheistic culture and immediately thinks that they do not have the intellectual resources that we have. Because I don't think why a Greek person like Socrates or Plato could not have said exactly the things that you said, St. Augustine said. I don't see why Zeus or Athena could not have said that beautiful forms. And your comment about the Greek gods are finite, well, maybe not. For one thing, we have the Dark Age intervening us and their time. So we do not have all the literature. But if you take someone like Plato or Socrates, I'm pretty sure they have the idea of the unity of God. So anything you say about St. Augustine could be said by a Greek. So this is number one. Number two is your talk is all about the beautiful thing God created, and here we run across the very old problem of evil. And who created that? So it is a very old and well-known problem, so you'll have to some explanation in your final conclusion about the ugly parts which are not quite mathematical, or the mistakes we make when we take a course in mathematics. Somebody has to create that. Third thing, about your conclusion slide, I think Spinoza can embrace all of that. Substance is equal to God is equal to nature. So there is no creation, but there are beautiful forms. There is appreciation of beauty. And everything's run as usual. Substance is equal to God is equal to nature. You do not need a creator.
Yeah, okay.
All you need is creation itself.
Spinoza is going to be complicated. I mean, Spinoza does, in a way, have a kind of Augustinian ideas in the mind of God picture, except it's a pantheistic version. So I think that's correct, that a lot of the things that theism can do here, pantheism can do as well.
Yeah, exactly.
That's right. So yes, there are other theories. What it is, I think, mostly evidence for is for some theory of an infinite kind of God. Let's see. Before that, we had the Greeks. I think you're quite correct. We may not have all. We may not know quite what the what the religion quite was. I think it's quite possible that. Well, no. Let me take this back. I wasn't objecting to the idea that they might have this idea of forms of beauty. I was thinking of this idea of the infinite. The Greeks were kind of allergic to the infinite. It was kind of like, it's the apeiron, the indefinite. You sort of kind of hear them kind of holding their nose at it. It's kind of fuzzy, and they didn't really like it. And they're now the gods. I don't know. Socrates may well have had a picture of a God who's infinite. I don't know if he was a polytheist or a monotheist or what he was. his picture of God was a perfect being, but they killed him. And they killed him for atheism, in part. And that suggests that that wasn't the general, that his belief in God wasn't the general belief in God in the culture at large, that he had something else. And so I think they didn't recognize in his beliefs what they did. And so that's, I think, some evidence that they actually were, that their gods were kind of limited and finite. Now, what was the third question?
The problem of evil.
The problem of evil, of course. That's the one I'm trying to escape, right? Yeah. 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 No, that is, of course, a very different set of topics. And there's really no way to, give a fair answer to that briefly. And of course, that is going to be true. I guess I could say one thing, sort of as a general philosophy of science thing, is that any theory that applies to a lot of cases is going to have anomalies, is going to have things that don't look like they fit. But it also seems like a bit of an understatement to call the evils of the world an anomaly. But it is something. And I think one should also maybe bring in here some Augustine's idea of evil as a lack of a good and things like that. But, my own view on the problem of evil is that is a fairly standard one, that the kinds of virtues that are really valuable, we couldn't develop. The kind of human virtues that are really valuable, we can't develop without an encounter with evil. But I have nothing very original to say about that. Great questions.
Go ahead.
Thank you so much for the talk. I learned a lot. And yeah, so I think the first point she was raising about the Greek gods and how they saw themselves as finite, I'd like to tag on to that. So I was thinking, the Greeks didn't see themselves as individualistic people. They saw themselves more as part of the group. You can see that in their idea of polis.
We don't do any of that. For one thing, the Dark Age had wiped out half of the literature. I'm pretty sure that if you take the standard student out of Plato's Academy or Aristotle's Lyceum, they would be able to give you much of the stuff that these taught embodied. So I'm not sure that they did not have individual thing, they did not have a sense. After all, the entire Western civilization stands on their sense of beauty.
Well, I feel like...
Go to any museum, what you see are Greek statues.
Yes and no. The thing is that they didn't really have a sense of individuality. They didn't feel like they didn't have that sense of going to heaven or being, having salvation or all these individual notions that Christianity has. Christianity really...
They certainly believed in an afterlife. We're getting a little off topic here, but they certainly believed in an afterlife with an individual judgment.
Let us keep on to the topic and finish your question to the
So
speaker.
now that's what I was going to raise to you, just as a counterpoint.
How come another day?
Yeah, I know. And then the other point was on mind dependent. Is that the same as intuitionism, or are they different?
No, intuitionism in the philosophy of mathematics is a very specific view that has very little to do with intuition, actually. It's the view that the law of excluded middle is false. Or, not false. It should not be assumed. That you should not assume that P or not P. And so that's a very different thing. There's such a thing in philosophy as intuitions, maybe, which is different, which is the idea that most of our insight into certain kinds of questions comes from intuitions.
No, I'm referring to the philosophy of thought.
Yeah, no, that's, I think, a very different thing.
Okay. Thank you.
I find very interesting the idea of numbers and mathematical facts as being thoughts in the mind of God. However, these a little bit struggles with the Aristotelian theory of the four causes. Could we say that we could add another cause to that theory? For example, an exemplar cause that relies in the mind of God?
Maybe. I mean, I don't know that we need to. I mean, the ideas in the mind of God, they're, whatever causal import they have can come from God's efficient causal power.
Yes, I'm curious, I just wonder, because from a perspective, beauty can only exist if there is ugliness, no?
I don't know. I'm kind of inclined to think not. I think that, I think you can have beauty without ugliness. I think we appreciate beauty a little more when there's ugliness to compare it against. But I don't think I have to taste disgusting food to enjoy good food. I don't think, yeah. So no, I'm not inclined to think the contrast is needed. It maybe helps us appreciate it, finite beings as we are, to see the contrast.
We had another question to say?
A question about the gap between mathematics as a descriptive language of the world and, let's say, a philosophical or personal experience. So, as an example, we take a leaf and say that the greenness of that leaf can be described mathematically as a spectrum of light with a specific number. And that helps us to communicate what we're talking about to somebody else who doesn't have to see that particularly. But does philosophy have something to say about the gap between the number and the thing, or is it just?
So, I mean, there's going to be many answers. The one I like is just something like the number exists in the mind of God, and God creates the leaf in light of that number. Outside of this kind of theory, you'll have other stories. There is a small minority of physicists these days who think that there is no gap, that we actually are mathematical objects. And we live in a mathematical universe, not in the sense of a universe described by mathematics, which is the picture I was pushing, but in a world that is actually made of mathematics. This is like the Pythagoreans thought this, and there's modern people who think this idea, and we're sort of part of a mathematical theory. That would be a sort of radically different kind of story.
Thank you for your lecture. I'm curious what you think about the idea that if a form and a shape is mathematical evidence of God, then that form and that shape is good. So, like, coming from dirt, which is potentially chaos, into a beautiful geometry, can be likened to God taking a formless tohu vabohu earth and creating form. And then also the fact that good music is good music and bad music we would consider noise and chaos. So do you think that that supports that good is found in form, and then the evil that we were talking about is actually just formless and patternless and a disintegration into chaos?
That's what Augustine thinks. I'm actually not fully on board with Augustine there, because I think that there is sometimes evil. Well, I don't think evil is a thing. So I'm with Augustine there. Evil is not a thing, it's not a substance. But I think it's more than a formlessness. It's sometimes opposed to it. So imagine, so take somebody who thinks that lizard people run the United States government. Right? So you've got a conspiracy theorist who thinks that lizard people run the United States government. They're not just missing a truth about the fact that it's human beings running the US government for good or for ill, right? they're not just lacking a truth. They have something that's opposed to the truth. They believe something that is false. So you could have like two kinds of people, right? Sort of, you've got the more moderate people who say, "I don't know who runs the U.S. government. Maybe it's lizards, maybe it's aliens, maybe it's humans. I don't know. Maybe it's angels, maybe it's devils, maybe it's God directly. I don't know, right?" So somebody just doesn't know at all, right? And then you've got the people who've got the right view, which is that it's human beings who run it. And then you've got people who've got like the false view that it's secret lizards that are running it, right? And so so the people who just say, "I don't know," that's kind of like the formless kind.
So that could be kind of
And that's not really that evil, maybe. That's not the really bad is when you have the wrong, when you're not just ignorant, but when you don't just not know, but you think you know and you're wrong. That's the really bad thing, right? And so I think that's a little bit more than formlessness. There's a belief there that's false. It's not just a lack of belief. I don't think, though, that there's still a kind of formlessness that there's a mismatch, right? There's a mismatch between their belief and reality. Their reality is flawed humans, and their belief is lizards. But so the mismatch maybe is kind of like a formlessness, but it's not quite that. So I think I want to cavil at this a little bit.
So then can I just ask them, for the evil, in that case, I got an impression it got to do with intention. But based on what both of you have said, it doesn't have an element of intention, does it?
Well, so, yeah, I mean, this evil is English is kind of has this word evil, and it's a little strong. Other languages that people have done philosophy in have a word that is used interchangeably for evil and bad. My native language is Polish. It doesn't distinguish between evil and bad. Latin has malum, doesn't distinguish between evil and bad. I think when I, as a philosopher, think about these things, I don't distinguish evil and bad. I just think something's bad. Now, when it's really, really bad, I'm more inclined to call it evil, right? So evil is more of an intensifier than something different. And so some bad things are there because somebody has bad intentions. But other bad things are just bad, like it's bad for me if I break a leg. And nobody has any intention to do that. And then, abstractly, if I talk about the problem of evil, I might not call my leg breaking a part of it, or I might. Starvation is an evil, often it's brought about by people acting intentionally in bad ways, bad governments acting badly, but not always. Sometimes it's just brought about by weather patterns that are beyond people's control. And in both cases, I would just say that's an evil.
So we have time for one last question.
Thank you. So I appreciate the structure of the presentation. I think it was wonderful. Would you, and I want to see, would you find it appropriate or maybe interesting, worthwhile to say, have a presentation that says God, beauty, and language, where grammar functions, where logic functions here, and we see, everything. We understand the beauty of language in the same way that you're talking about math here, because God seems to have used his language in his creative expression and
yeah,
so on
maybe
and so
more
forth.
broadly. That's very interesting. Yeah. I think there is something from the language. I think it's in some ways similar to logic and grammar. There's some specific things about language. I guess I might as well just give you this. So I'm really fond of this puzzle, and I think God maybe is one of the best answers to it. So you take language. Language has meaning. Where does the meaning of a bit of language come from? Well, it tends to come from something else that has meaning. Typically, another piece of language or a gesture, right? So you explain words to people, right? You look in the dictionary, and words will be explained in terms of language. Now, we can't do that all the time. Sometimes we'll just point things, So what is a nose? It's this. This is a nose. Everybody see this? So we do this with our children, right? We don't like explain in words what a nose is. We point to it, right? But the pointing itself has meaning. It's a gesture with meaning. It means the thing that you get by going from the knuckle to the fingertip and finding the next relevant object, right? So when we explain words, we explain them by other things that have meaning. When we explain things that have meaning, it seems like we have to use other things that have meaning. And so language keeps on shifting over the centuries, drifts, but it's like new language built on other language or on gestures. But it can't go on forever, right? Because, I mean, this is one case where, so people wonder, could the set of causes for the universe go back forever? Big questions there. I've written on this. Other people have written on this. But forget about that. We know that language can't go back forever because there was no language 10 million years ago, right? It doesn't go back forever. So somewhere we've got to stop. And so somewhere we have, and likewise meaningful gestures, before there was life on Earth, right? We've got to stop somewhere. So somewhere we come to things that have a meaning of their own in the physical world around us. And that's very strange, right? I mean, you have some kind of scribble or something. How could, this scribble have a meaning on its own? Well, this one doesn't. This one got its meaning from us. But some things have to have meaning on their own, and that's strange. And so you might think, well, maybe the better story is that they got it from God in some way. Okay. Now, there's going to be other theories you can give to that, but other answers to this. But it's at least there's something about this phenomenon of meaning that points beyond the physical world.
Thank you.
Thank you, Professor Pruss, for such a wonderful talk. We are the Thomistic Institute, a student-led organization that aims to promote the Catholic tradition, intellectual tradition. If you're a UK student and wants to join us, please look for us on Mindtracker, send us a message and we'll reach out to you. If you're part of the community, we'll send out an email. If you're signing, don't forget to sign in if you didn't. We'll send out an email about our next event. Actually, our next event is titled Middle Dark Ages and the Golden Age of the Catholic Church. That will be imparted by Professor Brad Gregory from the University of Notre Dame, and it will be happening in November. I don't remember exactly the date, but we will be sending an email if you are interested for our next talk. Thank you and have a good night.
Thank you.
Yes.
But there are three mathematicians here. You see, the mathematicians are